continue with the preparation of alcohols. In our last class, we have studied the first method of preparation of alcohol by hydrolysis of alkyl halides. Today we will study the hydration of alkenes. Now this hydration of alkenes can be classified into three types. The first one is acid catalyzed hydration. This is the direct method. The second one is oxymercuration, demercuration. And this method is the Markovnikov's addition of water. The third one is hydroboration followed by oxidation. With the help of this method, we add water to an alkene according to anti-Markovnikov's rule. So this is anti-Markovnikov's addition of water. Now these two methods, that is oxymercuration, demercuration and hydroboration, oxidation, these are indirect methods of hydration. And first one is the direct method. Now let us discuss the acid catalyzed hydration of alkenes. Acid catalyzed hydration of alkenes. Now in this method, we will add water to an alkene. Let us take our alkene to be ethylene. So ethylene plus water in the presence of dilute acid. Let it be dilute sulfuric acid. So H will add to this carbon and OH will add to this carbon and we will get ethyl alcohol. So acid catalyzed hydration of ethene is a very good method for the preparation of ethyl alcohol. We know that ethene is a symmetrical alkene. Now instead of ethene, if we use an unsymmetrical alkene, for example prop-1-ene, let us see what will happen. This is prop-1-ene. Now this is not a symmetrical alkene, this is unsymmetrical because the environment of this carbon and this carbon is different. Plus water in the presence of dilute acid. Here I have written H+, so this is representing acid. Now in this case what will happen? Water will add to propene according to Markovnikov's rule. Now OH minus is the negative end of water. So OH minus or the negative part of the addendum will go to that carbon atom which contains less number of hydrogen. This is Markovnikov's rule. So OH will come to this carbon and H to this carbon. So CH3, CH, this is this OH, then carbon, 1, 2 and the third hydrogen. So we will get propan-2-ol. Now this is the second method of hydration of alkenes, oxymercuration, demercuration. And by the help of this method, we will add water to an unsymmetrical alkene according to Markovnikov's rule. Now see, this alkene is given to you, and here I have written what? Mercuric acetate. So when an alkene is treated with mercuric acetate in a mixture of tetrahydrofuran and water, followed by reduction with NaBH4 in alkaline medium, what will be the product? The product will lead to simple Markovnikov's addition of water. So here you see I have written H2O. So what will happen? OH will go to this carbon and H will come to this carbon, and the product will be RCH, here OH, CH3. So this oxymercuration and demercuration will lead to the Markovnikov's product. That means water will add to this unsymmetrical alkene according to Markovnikov's rule. Now this first step is oxymercuration and the second step is demercuration. Now let us see this stepwise. First you will write this equation in your copy. Now we will discuss the oxymercuration and demercuration step by step. Let us take the unsymmetrical alkene, that is RCH double bond CH2 plus mercuric acetate. So let us draw the structure of mercuric acetate. This is mercuric acetate plus the process is hydration. So plus water and the medium is tetrahydrofuran. So what will happen? This OH will add to this carbon. Now this part HgOCOCH3 will add here. What is left behind? CH3, C double bond O, OH. That means plus acetic acid. Now this step is known as oxymercuration. This is the first step. Write this. Now the product formed in the first step, this is the product that is formed in the first step, is treated with reducing agent NaBH4, that is sodium borohydride. So this compound is treated with NaBH4. And what is the medium? The medium is alkaline medium. Now, this sodium borohydride will reduce and replace this acetoxymercury group. Let us see what will be the product. H plus we will get mercury is set free plus acetate. So this is our organic product. What is this? This is alcohol, and this step is known as demercuration. So the net result of oxymercuration and demercuration is the addition of water according to Markovnikov's rule. Our starting alkene was this and our product is this one. That means water is added according to Markovnikov's rule. So today we have studied hydration of alkenes. The first method was acid catalyzed hydration of alkenes and the second method is oxymercuration and demercuration. In our next class, we will study the third method, that is hydroboration oxidation. Thank you. Have a nice day.